today's lecture, we'll learn about the layout of a NAND gate. So first open the terminal window by pressing Ctrl Alt and T. Then type magic -T SCMOS NAND 3. So NAND 3 is the name of the layout. Press enter. Wait for the two windows to open. So this is layout window, this is the TKCon window. Now type grid in order to grid in. Shift Z to zoom out. Select the area and then type paint anvil. So this is my anvil, and then I need the P diffusion. So type paint pdiff. So pdiff is for my P diffusion, and press enter. This is my P diffusion. So I need four such boxes. Now I need my N diffusion. Type paint NDiff. Okay. Now we have to short the VDD of both the MOSFETs. So this part will be my shorting and this part will be my ground. I'll connect a metal over here for my ground. I'll connect two metal over here for my VDD shorting. So I'll select the area and then type paint M1. Then this same area I'll rotate clockwise 90. See, my area, whatever area I had selected has been rotated clockwise. Then paint M1. Paint M1. Now select the area. Now I can just select this area and then place it over here. Then type paint M1. Okay. Now both of my VDD are shorted. I'll place a contact. Paint NWC. Anvil contact. So anvil contact, here it will be P diffusion contact. Since my anvil contact will be placed in the metal, P diffusion contact. So the same area over here, paint P diffusion contact. After that, after this, I'll extend this area by typing paint pdiff undo, it should be NDiff. Undo means it will go for, it operates same as the Control Z. After that, select the area and then type paint M1. Okay. Now I'll extend this M1 for my, indicating it as my ground. Paint M1. Okay. Now select this portion type paint M1. Paint M1. Now this has to be shorted with the PMOS. So type clockwise 90. Paint M1. And again paint M1. Roughly the sketch has been done. Now here place the contacts. Paint and diffusion contact. Select the same area, place and type paint NDC. The contacts are placed since these are the metal and this is my N diffusion layer, and here also we need one more contact. Paint PDC. Any other contacts over here, the N-well contact, NWC. Selecting the same length, type PWC. Okay, the N-well contact, the P-well contacts are given. Now the poly, so type paint poly. It should be paint poly. So this is my poly contact. This is my poly. So select the same over here. type paint poly. Now the poly has been painted. Now nothing else left out. The only thing is labeling. So for labeling, select the area. Let me zoom in. Select the area, press the right click on the left corner over here. So you got a dot. Then type label A. This is my label A, and this is my label B. Label and label B. This is my VDD. And this is my ground. And this metal contact, this metal is my output. So I'll write it as label out. Now Shift Z. Now you can see the complete layout of the NAND gate. Now I'll save it. I can type save NAND 3, or directly you can save the layout. Then type ext extract. Then ext to sim, ext to spice. Now I want to see. So this is my NAND 3 magic extraction file, sim file, and the spice file. Then exit. Now we'll learn how to draw the layout of a NAND gate without using the commands in the TKCon window. So we will use the toolbar that is present in the layout. So first open the terminal window, press Ctrl Alt and T and type magic -T scmos NAND 4, then press enter. Now this is my layout window. So now how will I grid in? I'll grid in by pressing G, not by typing grid. Okay, now I want to zoom out, then I'll press Shift Z, go to options and then the toolbar. So select the area, and then middle click on the envelope and extend the area. Okay, now the P diffusion. This is my P diffusion. This is my envelope and this is my P diffusion. Next is my metal. Then middle click on the metal one. Okay, now I have to short the VDD of both the NMOS and the PMOS. So I can directly select from here, middle click on this metal. Okay, now we need uniformity, so all should be of equal micron. Now I don't need this part, so I'll select, I'll remove, and this part will be painted with N1. As I said, we need uniformity, so now this is uniform. After that, the P diffusion layer, select the area and then go for, sorry, this is the N diffusion layer. This is my N diffusion, extend it. Okay, now I have to connect these two, so select the area and middle click over here. Now this is too much, I'll remove this part. After that, extend it, since we have to join, middle click. Now from here to here, so we'll go with the phase wise, middle click. Okay, now these two are shorted. Next is my VDD is done. Now my ground. I'll just extend one more line over here. Okay, now my VDD is done, ground is done. Now I have to make the input, the two inputs. Since this is my output, my two inputs, short the gate. And then middle click on the polysilicon layer. So now the same way, another polysilicon over here. Okay, let me first paint this part, then I'll extend it, easier for me. So it's very easy to draw the layout, because the moment you want to select, you can select from here or you can directly select from here. If you want to remove, then just select and press outside, middle click on outer of the boundary. Now roughly my layout is done. Now next is my contact. So select the area, when here I want to extend it. Okay, I'll select this one, and then my poly diffusion contact, PD contact. Another PD contact over here. Okay, next the N diffusion contact. So this has become too thick. Now we have to place the NWC contact. NWC means our N substrate contact. This is my N substrate contact. I can place it as many as amount as I want. I'll just select and the N substrate contact. I can place as many as I want. As many I place, that is good. So similarly over here, the P substrate contact. Okay. Now I'll save it. Save the layout, right? Yes. So after placing the contacts and after saving, I'll save it once again. Yeah. I'll label it. So this is my VDD. Similar way. For labeling, I have no other option other than typing the label command. So label VDD, then label ground, label A, this is my label B, and this is my output. So let's label out. Finally, this is the layout of my NAND gate. Then I'll save it. I can directly type extract or extract all, then extract to I'll extract to the spice file and the sim file. So I'll see whether it's there or not. So here are my 4. Okay, I'll type quit. If I type VI, NAND 3, so if I want to exit from these kind of windows, then I have to type I'll close the terminal. Again I'll open it, Control Alt and T. VI NAND 3 dot spice, let's say. So, okay, here a new spice file is open. So this was all about how to draw a layout. Suppose we want to see this spice file of the NAND gate, then open the terminal window by pressing Ctrl Alt and T, then type VI NAND 4 dot spice. So this is a spice file of the NAND gate, spice 3 file created from NAND 4.ext. So the scale is 1 micron, and here the similar way M1000 is the MOSFET. Then this is my drain, gate and source and the body. This AD is the area of diffusion, PD is the perimeter of diffusion. That's written 63 and 32. Similarly, this is the area of the substrate and this is the perimeter of the substrate. This is the WL, you can find the WL ratio. This is the PFET. So these two are from my PMOS and NFET. These two are my NFET. So since these are 4 MOS, you can see 1000, 1001, 1002, 1003. So these two are my PFET, these two are my NFET, and according to my labeling, it's already written over here. This is out A, this is VDD B, then this is the NMOS, and this is also the NFET. And here also it is written here ground, out, B, A, and VDD. So we had two inputs AB, my output was out, my source was VDD, and my sink was my ground. So that we can find all the values of each corresponding MOSFETs over here in the SPICE file. And you want to exit, then press colon and then WQ. This will bring you back to the terminal window. Type ls. I can see all the files that I have created till now.
Now let's see how to draw the layout of a 2-input NAND gate from the normal schematic diagram. Now let's open the terminal window by pressing Ctrl Alt T. Type magic. It's very easy and very simple to draw the layout from the twisted schematic diagram. So now let's see what's the difference if I try to draw the layout from the normal schematic. Type grid, zoom it. So first we have to design two PMOS, paint and well, two PMOS and two NMOS. So since the PMOS were in parallel, so we have to design it two separately. Now select the area. Type paint, pdiff, paint, pdiff. Now draw the end diffusion layer. We make it end diff. We make it bit longer. These are shorter because these are single PMOS. But here we are giving two NMOS in series. So they'll have a common drain, common drain and source combination. So now let's place the poly paint poly. Paint poly. Now let's make it more longer. Paint and dip. And again paint and dip. Okay. Now we have to make a poly layer for the PMOS. Paint poly. Paint poly. Now we have to extend it to this level. Type paint poly. Now we have to connect gate to gate. Now have to connect this poly with this poly. Type paint poly. So this PMOS is connected to this NMOS. Similarly, paint poly. Let's name it. Simultaneously we can name it also. Name them. Make a rectangular square. Right click on the left button. Label A. Then label B. Label B. Okay, now the NMOS and PMOS are ready. So now these two are the source terminals which are connected to the metal layer. So type paint M1 and now we have to connect from here. Paint M1. Let me make it shorter. Paint M1. So I will try to see whether there are any DRC errors. So there are no DRC errors. Similarly, paint M1. Now these two terminals are now connected to VDD. Okay. These two are connected to VDD and these two are shorted. The two drains are shorted and connected to the drain of the NMOS. Type paint M1 and from here to here, paint M1. Now this is the drain terminal, drain terminal, drain terminal. Three drains are shorted and the source is connected to ground. Paint M1. Okay. Now we have to place contacts before designing the inverter. Select the area. Since this is a P diffusion, we have to place P diffusion contact. Paint P diffusion contact. Contacts are very important and very necessary, otherwise the layers will remain overlapped without being in contact. Now this is the N diffusion layer. So N diffusion contact. paint and diffusion contact. Okay. Now we have to design the inverter. This is our output. Now we have to design the inverter. Paint anvil. Paint V diffusion. Then paint and diffusion. Okay, now I have to place the poly contact. Erase. Paint poly. Now connect these two poly. Okay. Now we have to connect this to VDD and this to ground. Type paint M1 and we have to connect these two drains. Paint M1. Okay. Now we have to connect. This is the input of the inverter. This is output of the NOR, output of the NAND. So connect this. M1 paint poly. So we need a poly contact over here. The metal and poly are overlapped. Poly contact. So now you can see exactly how the PMOS and NMOS are arranged. So we have to place some more contacts over here. Paint PTC. PDC. Paint NDC. If I want, I can increase the width of the end diffusion layer so that this joint is exactly visible. Similarly, it's so done so that you can see, we can distinguish between the N diffusion, P diffusion layer and the contacts. So now just zoom out. You have to name this VDD. Label VDD. Label ground. We don't need this portion, so we can remove it. So this is the whole layout. We have given the input and this is the output. Label white. So this is the whole layout. This is the layout of a NAND gate from a non-twisted schematic. If we want to save it, save NAND 6. Extract all. Extract to spice. Now we have to exit. Type VI NAND 6 6.spice. So you can see the variation in the pfets width and length and the nfets width and length. Here it's 627373, 536253. This is according to what we have drawn in our layout. This is the perimeter of diffusion, area of substrate, area of diffusion. If I want to see my layout, I will type magic NAND6.mag. So this is now the whole. This is now the whole layout of a two input. This is now the layout of a two. Now let's see how to draw the layout of a NAND gate by using cell instantiation. We will use an AND gate and then try to draw the NAND gate. So first, grid in, zoom, I write get cell and 3. This is the and 3 cell. Select the area and press X. So this is the NAND gate. NAND gate plus NOT gives AND. Again AND plus NOT will give you NAND. So select area, type paint envel, then type paint P diffusion, paint N diffusion. Okay, now this is the layout of a inverter. We are drawing the layout of a inverter. Paint poly. We need metal layer also. Paint M1. Paint M1. Similarly, this is VDD. Paint M1. Paint M1. Now these two are shorted. These two drains are shorted. Paint M1. Okay. Now the output from here will be given as input paint poly. Now place a contact, paint poly contact. Okay, now this obtained output is AND bar, that is NAND. So we will name it as label out, because here This is written as label X. Now type save NAND 6, NAND 7. Similarly, extract all. So you can see, since we have used cell instantiation, it is extracting from AND3, also from NAND 7. Then extract to spice, exit, VI, NAND7.spice. You can see it is giving the location as and3_0/a_27_23. So this part is the cell instantiation part. If we want to see the layout, type magic NAND7.mag. So you will see the cell instantiation part, and this is what we have designed. This is the inverter. I'll select this. If I press X, then I can see the whole part. So this is my whole layout.